Okay, so we are going to start looking today at arithmetic sequences and partial sums. The last section was basically an overview of all kinds of sequences and series and sums and things like that. So now we're going to, these next couple of sections, we're going to narrow it down a little bit. And this section in particular is going to talk about arithmetic sequences and series. And the next section after that will be geometric. And we've talked about arithmetic and geometric sequences and things like that in Algebra 2. So just a reminder of what those actually mean, right? And arithmetic means the same thing as added or subtracted from each term, okay? So for instance, we have 2, 4, 6, 8, 10, right? You add 2 each time, okay? Or you could subtract something each time. So if we had 100, 95, 90, 85, and so on, you'd have a -5 that's subtracted each time. A geometric series, or excuse me, a geometric sequence is similar. However, this time it means that there's something being multiplied or divided each time. And we'll focus more on that in our next section. So what those would look like would be like 2, 4, 8, 16, 32, which that would be times 2 each time, that kind of a thing. But today, since we're going to focus on arithmetic, let's get focused in on that. Okay, there are a lot of formulas that you're going to need to know and remember and know how to use them. One of them is the formula for finding the nth term of an arithmetic sequence. Okay, and that's a formula. It's highlighted. It's one of those that you're going to need to know. One of those that you should just tattoo on the back of your eyelids as a formula that you should be aware of. Okay, and again, this is going to give us a rule for how to find any term in the sequence. Okay, so a sub n represents the nth term. Okay, so if we're looking for the 15th term, it'd be a sub 15, something like that. A sub 1 is the value of the first term. N is the term in which you are using, and D is the common difference, how it changes each time going from one term to the next. So we're going to find a formula for the nth term of an arithmetic sequence whose common difference is 3 and first term is 2. So let's just make note of some things that we know here. We know our D, our value of D, which is our common difference, is 3. And our first term, which is a sub 1, equals 2. So if we come right back up here, I'm just going to write down our formula. We're going to have a sub n equals a sub 1 plus n minus 1 times d. We are just going to write what we know here. So I know that a sub n, I know my first term is 2. I don't know anything about n, so I'm going to have n minus 1, and then my difference is 3. And what I'm going to do here just to simplify it is I'm going to distribute that 3 into my parentheses. So I'm going to have a sub n equals 2 plus 3n minus 3. And when I combine my like terms, my rule is a sub n equals 3n minus 1. So there's my rule. Once I know what my rule is, I can actually figure out any term that I want in the sequence. So if I want to know the 18th term, that's mean I would be finding a sub 18. So anywhere I see an n, I'm going to put in my 18 minus 1. 3 times 18 minus 1 is 53. So if we continued counting, if we started at 2 and we added 3, we'd get 5, plus 3 is 8, plus 3 is 11, and so on and so on. When we got to our 18th term, we would be at 53. Okay, so the other thing that we can do with arithmetic sequences is we can find the partial sum of a sequence. Okay, just like we did before, except of course, now that we're specifically looking at arithmetic sequences, we have a formula that we can use. Okay, and here it is, highlighted in yellow as a formula that you need to know. So S sub n is the sum of the first n terms of the arithmetic sequence. N is the number of terms in the sequence, the total number of terms. A sub 1 obviously is the first term, and a sub n is the value of the nth term in the sequence, okay? So if we are going to use that to find the sum of the following sequence without just putting it into your calculator, 1 plus 3 plus 5 plus 7 plus 9 plus 11. Sometimes there's a lot of numbers in there that you don't want to have to enter all those in your calculator. We can use our formula where the sum of the n terms is n over 2. Then you're basically just adding your first plus your last. Really all that you're doing. So in this case, we're asking ourselves, we're finding the sum. How many terms are in the sequence? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 terms in that sequence. Okay, so n equals 10 terms. So if I want to find the sum of those first 10 terms, I'm going to have s sub n, because I have 10, is going to be anywhere I see an n, I'm going to put in a 10. 10 over 2. My first term I know is a 1. My last term I know is 19. So if I do my math, I have 1 plus 19 is 20. 10 divided by 2 is 5. 5 times 20 is 100. So using your formula, or if you actually calculated it 1 plus 2 plus 3 plus 4, or 1 plus 3 plus 5 plus 7, and so on, you would get 100 as the sum. That's not the 10th term, that's the sum of the first 10 terms. Okay, so the first 100 integers. Remember, the first 100 integers start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So we're basically looking at 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7, 8, 9, 10, skip a few all the way up to 99, 100. That's how some of us probably used to count when we played hide and seek. 1, 2, skip a few, 100. So we're going to use our formula. The first 100 integers, so we're going to find the sum of the first 100, means that we would have n over 2. N is 100, so we're going to have 100 over 2. Our first term is 1, that's a sub 1. Our last term is 100, so that's our a sub n is 100. So we would have 50 times 101, which would be 5,050. So if we added 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way up to 100, the sum would be 5,050. Okay, so let's do some other applications here of how we can use this. So with partial sums, okay, so if we are finding the 16th partial sum of the sequence, okay, just keeping in mind our formula, oh, I have it written down there. In order to find a sum, we have to know how many terms there are in the sequence, we have to know the first term, and we have to know the value of that last term. So in order to do that, the first thing that we are going to have to do is know what our rule is in order to find any term in the sequence. We're going to need to know what the 16th term is in this case. So in order to do that, we're going to use the information that we have to write a rule. Okay, so the first thing we're going to do is we're going to write a rule. So we can find any term that we want. We're going to use our formula. We're going to have a sub n equals a sub 1. Well, our first term is 100 plus n minus 1. And our common difference, it's going down. So our a sub 1 was 100. Our difference, it's going down by 5, so that's going to be negative 5. So we're going to have a negative 5 out here that we need to just distribute in there. So our rule is going to be a sub n equals 100 plus negative 5n plus 5. That's what I get after I distribute that negative 5 through. So my rule, again, is a sub n equals, well, 100 plus 5 is 105. So we're going to have negative 5n plus 105. So there's my rule. Then I use that rule. I need to know the 16th partial sum, which means I need to find the value of the 16th term because that's where I'm stopping. So I'd have negative 5 times 16 plus 105. So my 16th term, which is where I'm stopping, is going to be 25. Okay, so that's going to be one of the things. If we are finding the 16th partial sum, we need to know the 16th term because that's where we're going to end. So if we're going to find our sum using our formula, we're going to find the sum of the first 16. Okay, so anywhere we see an n, we're going to put in a 16. So we're going to have 16 over 2. Our first term we know from the top up there was 100. We are ending at our 16th term, so we're going to have 125. Or excuse me, not 125. We're going to have 25. When we put those together, we get 125. So our sum of our first 16 terms is going to be 8 times 125, which is 1,000. So if we kept this pattern up here going for 16 terms and added them all together, they would add together to equal 1,000. Okay, one more example. This is an application of how it might work. At a golf tournament, there are the 12 golfers with the lowest scores win cash prizes. Remembering in golf, low scores are good, so that means the top 12 golfers earn cash prizes. First place earns 1,000, so let's just kind of start writing out what our sequence is here. We'd have 1,000. Second place receives 950, 900, and so on. Okay, how much prize money will be given out? Which means if we are actually figuring out how much prize money they will be giving out, we technically would be adding these values together to find out how much they add up to total. And eventually we want to stop at the 12th term. Okay, we need to know how much that 12th term is so that we can find the sum. So just like that example with just a random sequence on the last slide, first thing we need to do is find our rule. So we're going to use a sub n. We're going to write a sub 1 plus n minus 1 times d. Our rule is going to be our first term is 1,000. That n minus 1 stays there, and our difference is negative 50. Okay, so our rule, when we simplify that, we're just going to distribute that negative 50. So we're going to have a sub n equals 1,000. Negative 50 times n would be negative 50n, and then negative 50 times negative 1 would be plus 50. So our rule is going to be negative 50n plus 1,050. Okay, so that's our rule. Now we use that rule to figure out what's our value of our 12th place payout. So the value of your 12th term, so that'd be a sub 12, it's going to be negative 50 times 12 plus 1,050. And when you put that into your calculator, you get that your 12th term, the 12th place person wins $450. Okay, so if we are going to figure out how many dollars are totally given out for the top 12 golfers, okay, we would do our S sub 12 because we're finding the sum of the first 12 is going to be n over 2. That's our formula. So we're going to have 12 over 2 times our first term, or our first money value that they give out, plus our last, which is the 12th, which is 450. So the sum at this golf tournament, the total that they give out, if we take 12 divided by 2 is 6, 6 times 1,450, they give out $8,700 in cash prizes. So there's an example of how you might actually use some of this stuff in real life.